And now, dear students, you are going to solve more training exercises. And here we go with the exercise that we solved previously. It is here to solve this quadratic inequality. Okay, so first of all, we find delta. Again, we have to care about the sign of A. We put the roots on the table and we apply the rule of same, opposite, same according to the sign of the coefficient of x squared, which is a. Now, what happens in case we have the inequality in this form, in the rational form? So if minus 2x plus 3 over x plus 2 greater or equal to 0, we have to solve this inequality. So again, we have to find the roots of the numerator and the denominator. So the root of the numerator is by taking 3 to the other side, then we have minus 3 over minus 2, which is 1.5 as you see here, and the root for the denominator is minus 2. But we have to pay attention that when putting the roots on the table in the increasing order, as you see, minus 2 before 1.5, we put a 0 on 1.5, but we put dashes on minus 2. That's to remind us that the denominator should never be 0, should not be 0. Now, how can I put these signs? How do I know these signs? Let's see. When I have minus 2x plus 3 over x plus 2, it's like minus 2x plus 3. It has the same rule of minus 2x plus 3 multiplied by x plus 2. Without wasting time and expanding, we can directly notice that when expanding minus 2x by x, we will get minus 2x squared. And that means that a is negative. So this is a here is negative. Now, definitely, since we have roots, then delta is positive, and these are the roots. So we are going to use the idea of same, opposite, same. So again, how to notice the sign of A? So we suppose that this denominator is put as a product here, multiplied by minus 2x plus 3, and when expanding, it's enough to expand x times x and their coefficients. We get a negative coefficient. That means that A is negative. Then same, opposite, same. So the same sign of A, the opposite sign of A, which is plus, and here again the same sign of A. So again, outside the roots we have same sign of A. As you see, it's negative, and between the roots you put the opposite sign of A. And we need greater or equal to 0, so we need the positive part. Then we look here between minus 2 and 1.5, and the answer is opened interval at minus 2, 1.5. So this is the interval, that's the solution for this inequality. Why is it opened at minus 2 but we have or equal? Because minus 2 cannot be a value for x because the denominator will be 0 then. So even though we have greater or equal, we close it at the allowed value and we open it at the excluded value. Now let's continue and see more examples that we use quadratic equations in them. Here are some rules that may be used in solving inequalities. Okay? A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Note that the degree here is a 3, and here 2 plus 1 on b, it is a 3, and here a power 1 plus 2, it is a 3, and here is a 3. Similarly for here we have plus, minus, plus, minus. So as if we are going with a pattern. Here a cubed plus b cubed, we use these two most. A cubed plus b cubed equals a plus b into a squared minus ab plus b squared. If you want to make sure, you can expand these and you will definitely get a cubed plus b cubed. Of course, there are proofs for these identities using geometric shapes, using cubes and whatever, and later inshallah we may talk about these, and we may see videos or watch videos about proving these identities using cubes and so on. A cubed minus b cubed, we put outside a minus b, and inside and the other factor we have a squared plus ab plus b squared. Now if you want to make sure, again you can expand these and you will definitely get a cubed minus b cubed. When are these identities used? For example, if I'm going to solve x cubed plus 27 greater or equal to 0, this is not quadratic, but I can use quadratic. How? Let's see. I'm going to use this identity. Okay, so I'm going to use this identity in order to factorize x cubed plus 27. So what happens? X cubed plus 27 is actually x cubed plus 3 cubed, which is applying this rule. Notice a cubed plus b cubed, we take a and b here, so here we take x and 3. So x cubed plus 3 cubed, we take x plus 3, because we have plus here. Now here we have x squared minus 3x plus 3 squared. So just applying this rule. Okay, so again we are just applying this rule. Now we continue. We have to find the roots in order to put the roots on the table. So we have to find the root of x plus 3 and of this quadratic form. So x plus 3 is 0, then x equals minus 3. Now what about x squared minus 3x plus 9? Since it is a quadratic equation or a quadratic form, we have to find delta. Now delta here is equal minus 3 squared b squared minus 4ac minus 4 into 1 into 9. So it is 9 minus 36, which is minus 27. That is not positive, that is negative, and that means that there are no roots for this, and by this, because delta is negative, no roots for this on the table, and we have to take the same sign of a, which is definitely positive. So all of this is positive, so we don't care about it, we just care about the sign of x plus 3 on the table, because positive doesn't change anything. And here comes the table. Here comes the table. We put here, of course, minus infinity. And here we put plus infinity. And we just care, as I told you, about this factor, because this is the factor that's going to control the sign of all of this inequality. So, as you know, before the root, we have the opposite sign of x, which is plus here. So its opposite sign is minus. And after the root, we put the sign of x, the same sign of x. Because we need it greater or equal to 0, so we take this part, which is from minus 3 till plus infinity. And here we go with the figure of, or the curve of this x cubed plus 27. Look, this is the curve of it. Here is minus 3, the root, you see. And the solution, it is positive, means above the x-axis, the solution goes from minus 3 till this part. All of this part is going to plus infinity. Okay? So again, for this to be positive means it's above x-axis, and here is the graph where it is above the x-axis, from minus 3 till plus infinity. And finally, how to use all of these ideas to solve systems of second degree inequalities with one unknown. Solve the following system. If you have this system, it's a quadratic inequality in equation 1 or inequality 1, another quadratic inequality, let's call it inequality 2. So first of all, we solve the first one using delta and the rules and so on. Second, we solve the second one, and finally we make the number line to get the intersection between the two solutions. Okay, so let's start. Using the calculator, so I'm dealing with this one. So x squared minus 3x plus 2. Using the calculator, the roots are 1 and 2. And a, we always care about a, don't forget, equals 1, which is greater than 0, which means positive. Now let's find delta. So since there are two roots, then definitely delta is positive. So whenever roots appear on the calculator, then that means that delta is definitely positive. So maybe you don't have to find delta and waste time. So again and again, whenever the roots exist on the calculator, then you make sure that delta is positive. So we put the roots on the table, and we are going to use the idea of same, opposite, same according to a. So the roots are 1 and 2 in the increasing order, minus infinity plus infinity, same as a, which is plus, opposite to A, which is minus, and same as A, which is plus. And we need greater than 0 without or equal. So we take the solution from minus infinity to 1, this part, and from 2 to plus infinity, and both are opened at 1 and 2 because no or equal. So this is S1. Now let's take the other inequality. 2x squared minus 7x plus 3 less than or equal to 0. Again, using the calculator, there exist two roots. Then that means that delta is definitely positive. A is 2. Okay, so I just put the roots here, and the sign of A is positive, and we use the idea of same, opposite, same. So same as A, positive, negative, opposite to A, and same. Similarly, I need less than or equal to 0, so I need this part. Because I have or equal, so I close the interval at 0.5 and at 3 together. Now, here is the number line to sum up the solution. The solution is the intersection between S1 and S2, so we use a number line. And we arrange the values of the roots in the increasing order from the least to the most. So 0.5, 1, 2, and 3. According to the first solution in red, we have it from minus infinity to 1. It's opened at 1. Look, it is dotted here, or you can put it like this, no problem. You can put it opened like this and opened like this, no problem. And according to the second solution, it is from 0.5 closed to 3 closed. You can draw it as you want, either discrete or undotted, or opened and closed as you see here. Now, where is the intersection of the two colors, the red and the blue? It is between 0.5 and 1, closed at 0.5 and opened at 1. You just copy this one, okay? And union, there is another place which is between 2 and 3, opened at 2 and closed at 3. So that's how to solve inequalities in systems of inequalities, using the ideas of delta positive, same opposite same, and so on. Hope you enjoyed this chapter. It's really a very nice chapter, and see you later inshallah in more and more videos.